Okay, different question. In this question, we have a statistics class being surveyed, and they were asked whether they always wear a seatbelt in the car. Suppose there are 50 students in the class, and 30% of them respond that they do not always wear a seatbelt. How many students is this? So again, if I try to quickly reword that to a shorter question, it seems like I'm being asked basically the same question that I was just being asked. I'm being asked, what is 30% of the total 50 people? So again, I could write that as x equals 0.30 times 50. And multiplying that out, I get 15. Suppose in a different class, 20% of the students, which was 43 students, said they did not always wear a seatbelt. How many students are in that class? So they've asked a different question here. This is the total that we're looking for. So this is similar to the 50. So what we don't know this time is this number right here. But we do know 43. We know that 43 is 20% of, and this time we don't know this back part. So I can set up the same basic equation, leaving a different part blank. So 43 is 20% of something that I don't know. This time, in order to solve for x, I actually need to divide by 0.20. And doing that, I get that there are 215 students. And again, double check really quickly that this makes sense. If 43 was the part, there has to be more than that in the whole class, so this makes sense. Sometimes you may come across data summaries that are missing crucial information. So here's an example. We've got sports and we have injuries. So we've got baseball, basketball, bowling, and football, and we have the amount of injuries that have been recorded. At first glance, it appears that, to me, it appears that basketball is the most dangerous. It's got the higher number of injuries. However, let's add some more data. So what was missing down here was this idea of how many total participants are there. So there are 165,842 injuries in baseball out of 11,500,000 people playing. So what we want to do is we want to divide that out. If we do 165,842 and we divide that by the total participants, that will give us the rate of injury per participant. So make sure that you're doing this on your own. Work on your calculator. When I do this, I get this big long decimal, 0.0144210435. And I'm going to do likewise for the rest of them. So for each one of these, take the number of injuries and divide them by the participants, and do that for each one of these. Those are the numbers that I get. Make sure that you get those same values. Now those numbers themselves actually are a little bit difficult to use and to talk about also. So if we modify them one more time, let's change those numbers into the rate of injury per 1,000 participants. To change this from a single participant to 1,000 participants, we just need to move the decimal place over 3 places. So I'm going to move this one, 2, 3 places. That one would be about 14.4. This would be 20.5. This would be about 0.46. And this would be 50.8. And what this means is out of every 1,000 participants of the sport, in baseball, out of 1,000, about 14 people get hurt. In basketball, out of 1,000 participants, about 20 people get hurt. For bowling, out of 1,000 participants, less than one person can be expected to get hurt. And in football, out of 1,000 participants, 50 people are expected to get hurt. At this point, which sport would you classify as the most dangerous and why? Well, at this point, I would choose football. And here's my reasoning. Out of 1,000 players, out of 1,000 players, 50 are expected to be injured. And that's more than any other sport that we're looking at. Not any other sport ever in general, but any of the other sports mentioned above. So the takeaway from this is, again, in order to compare groups, the groups must be similar. If your data consists of counts, percentages or rates are often a better comparison because they take into account the possible differences among the sizes of the groups. So you cannot always create equal sample sizes. So in those cases, you need to be comparing percentages.